Hello, good afternoon. Good afternoon here in the UK, anyway, and wherever you may be in the world joining us. I'm delighted to introduce Ruth Pickering, who's the Chief Operating Officer of Yewno. And Ruth is going to talk in a minute about knowledge graphs, increasing content discoverability. This is the first of our new season of Content Live webinars. We're very excited to be back. Really delighted to have Ruth. Just in case you haven't attended before, we're going to run for 30 minutes. We'll have a presentation. That's going to be 20 to 25 minutes. Then we'll do some Q&A. We're using Zoom webinar today. Your mics are already muted. But everything, any questions you have, please do file them on the Q&A tab. The whole thing will be recorded. We'll get that recording to you as soon as we possibly can. Now, Ruth's Chief Data Scientist, Harris Dindo, did a webinar earlier this summer introducing AI knowledge graphs as a concept, and it was such an interesting and engaging session. We invited Ruth back to really underline some of the interesting factors, the importance to scholarly publishers. I'm just going to hand over to Ruth now, and she will take you through knowledge graphs, increasing content discoverability. Thanks, Ruth.
Fantastic, thanks, Clive. And I'm going to do a share screen. So here we go. Brilliant. So in terms of what I'd like to cover today, I'd like to take you through a little bit of background, really, in terms of where all of this came from. So what are the challenges that people are facing, and why are we really interested in talking about this knowledge graph technology? So in terms of what I'm going to focus on, it's starting off with the technology, but then it's really moving on to the value that publishers can get, and how AI technology and knowledge graph technology can really help people understand their entire collection. So everything from the front list, which generally gets quite a lot of focus, all the way through the backlist. And so in terms of where we're going to start, we'll kick off with a bit of the challenge and really going through the kind of evolution of the technology. And then we're going to go into some of the specific features of the technology and why it's relevant. And I've got a couple of examples from customers in terms of how they've used AI in their own kind of collections. And then we're going to have loads of time, as Clive mentioned, at the end for questions. So please do feel free to email in at any point or hold your questions until the end. So first of all, looking at the challenge that we're already facing in this environment. So for publishers and for content owners, you want your content to stand out from this kind of overwhelming volume of information that's available today, and you want your content to be found easily. You also want your content to remain up to date in terms of the language it's using and how it relates to other information. So you can see here from this slide that it gives a really good example of kind of that challenge and how we will face it really pretty much every day in terms of what we're facing, whether you're working in publishing or whether you're a researcher looking for content. It's a similar situation. So I'd like to talk a little bit, before I get into specifically AI and knowledge graphs, I'd like to talk a little bit about technical evolution and how we got to where we are today. So if you look at the left-hand side, you can kind of see where things started off with things like BISAC and keywords. So many decades ago, content was categorized so that it could be physically found on a bookshop shelf or a library shelf. And this is, of course, before the mass digitization of content and before widespread internet access. So if you look at the middle box, natural language processing, the technology has been around from about 1970, obviously came into use after that, and it was a huge step forward. But what NLP does is statistical distribution. So it's understanding co-occurrences, positioning, etc. It's not actually understanding the text itself. So it doesn't give you that context. And then if you look at where we are today with deep neural networks, we're now in an environment where artificial intelligence can actually understand context and meaning. So it's not simply hunting for keywords. So if you think about that, if you look at the little diagram at the top and you've got the three kind of orange blobs and a couple of blue ones and green ones, the key thing here is that if technology, if algorithms can read content and understand the meaning, they can accurately disambiguate and point people to the right section of documents. So you can see in the chart, we've got Apple, a company close to Microsoft, and Java, the programming language. We've got apple, same word, but this time the fruit, close to the other fruit pair. And the key thing here is that somebody who's looking for Apple the fruit doesn't want their results muddled up with anything to do with Apple Inc. So what it enables you to do through this understanding of context is really give very, very accurate results. And that's really, really critical to helping people find what they're looking for. So moving on to sort of AI in a bigger picture sense, how does the technology actually work? So on the left-hand side, you can see content. It can be any different type of content, anything from scholarly articles, books, book chapters, news, patents, clinical trials. And on the left-hand side, that's being created every day. And what happens is that it can be ingested in real time or as often as it's published or updated. And in the center, what's happening is a series of algorithms that are trying to recreate a neural network model will be reading that content. And the key thing is that they're going to be reading every single sentence, every single line. They're not just looking at the abstract. They're not just skimming through. They're reading the entire document, as much text as is available. And then on the right-hand side, you're creating this enormous knowledge graph. So it's an enormous multidimensional semantic vector space, and similar concepts can be clustered. So the key thing about this knowledge graph is that it's understood the text. And so as it identifies meaning in the form of concepts and promotes them into this knowledge graph, similar concepts will be clustered, but similarity can change over time. A new concept can come into the graph over time. So one of the most important things about knowledge graphs is that they are dynamic environments. So as things change, as things evolve, the relationships, the connections will change. And I think in terms of keeping content up to date, that's a really, really critical part of being able to do that. You can't be using a static environment. You have to use something that is constantly updated as new items of content are published. And so while traditional databases are great for organizing and structuring content and data, they don't necessarily understand the content. Whereas a knowledge graph, which has read and understood the full text of each document, can not only surface it or the relevant section of that content, but it can also make connections between concepts and documents and explain those connections. And I'm going to come on to some of that technology a little bit later in terms of how those connections, etc., can be made. But before we do that, I wanted to sort of explain a little bit further about knowledge graphs, because looking at the diagram on the right, it might be difficult to kind of really imagine a multidimensional semantic vector space. So what I'm going to show you here is a video. And as you can see here, all of the lines are changing. So this is a little video showing news that's being ingested in real time and a series of concepts. And as you see, each of those bars change and they all have labels. So the top one currently is Apple Inc., but it's just been overtaken by Huawei. Then the third one is IMF, and each of them has a number. So in a knowledge graph, which is a mathematical space, everything actually has a number, it has a value. So you can see as news is being published, as it's changing, you can see all of the numbers change. And this is really about how the importance of those concepts is changing over time, how the relationships are changing over time. And this is just a visualization to really help understand how information changes in a dynamic environment. So I'm going to move on next to a little bit about disambiguation. So in terms of maximizing the value of your content, if you're in the publishing business or a content owner, the first thing you really need to know is what you have. So if we look at this example here of depression, the first thing is what kind of depression are we talking about? So if depression was a keyword in some of your kind of taxonomy today and your keyword, what would you actually be talking about? So you might be talking about depression in geology. You might be talking about a low pressure area. You might be talking about an economic depression. If you were talking about an economic depression, it could be the Great Depression, the Long Depression, or the Depression of 1920-21. And it could also be a totally different kind of depression, the mood, and depression, the physiology, or a major depressive disorder. And Harris also touched on this briefly, but I'm looking at this from a different kind of point of view. So of course, if you did have depression as a keyword in your backlist, how would you actually know? You might be able to determine which kind of depression it was through some sort of blend of looking at the hierarchy. But the key thing is that the person who's looking for depression in economics is a very different researcher for somebody who's looking for depression in physiology or depression in the mood. So the ability of the technology to take all this single word, but to actually accurately disambiguate and provide the right kind of depression, and therefore help people find the right kind of information, is absolutely critical in terms of maximizing the value of content and actually understanding what you've got. The other thing that's really, really important, and we also touched on briefly before, is really about context and meaning. So you may have content that's older, and when it was originally published, the word or the terminology used to describe it might have been different, or the actual word might not have been mentioned at all because it might be sort of early phase research. So they might be using some kind of different terminology in terms of how they were describing it. So it's really, really important that you can actually identify older bits of your content that are relevant when a term is subsequently introduced. And the other thing that's really important is using this full text approach, taking people to the exact section of text. So a couple of years ago, a publisher said to me, how many people do you think get more than 50% of the way through a journal article? And I did not know the answer. And they said less than 5%. So today we're all overwhelmed with sort of real-time information and updates, but people are not generally reading large documents. We might read books on holiday, etc., but people really want to find something really quickly and then go to the exact section. They're certainly not going to wade through a 400-page book in the hope that it might contain something relevant to them. So being able to surface the relevant sections of text is really, really critical in terms of making your content user-friendly and helping people to find what they're looking for. And then the final thing, and again, one of the really important things that AI can help with, is keeping content up to date as language is evolving. So we've got people from around the world, but I always think of the Brexit example, because Brexit is a term that came into use widely from 2016. It's actually been a term that existed since 1964 in parallel with the use of the word United Kingdom withdrawal from the European Union. So people might be using either of those interchangeably. And so if you were doing a search on either of those, you'd certainly want all of the relevant documents from either term or group of words to be surfaced. You wouldn't specifically, if you're looking at Brexit, only want that, or vice versa. And the other example, which I think is particularly important and really also in science, is the fact that names will change over time. And if you start looking for something that's been called a certain name in 2020 that was previously called something different, you'd absolutely want to be surfacing the relevant content from that as well. So as we move into the world of AI, we start moving from calling a keyword into a concept. And there's a key distinction between what a keyword is and what a concept is. And we've seen how important that is, because as we look at something like Jaguar, we can be talking about a car, a World War II tank, a cat, etc. And so the person who's looking for Jaguar is definitely looking for distinctly different things in each of those three definitions. So in the world of AI, a concept is not just the word or the group of words. It is the word or group of words plus a definition. And that disambiguation, which is possible through AI technology and knowledge graphs, which are actually understanding the content, is one of the key differentiators in terms of how this technology can really help people in the world of publishing. One of the other things I wanted to show you was really another dimension that AI can help with, and that's really around visualization. So all of us are visual learners, but as we are educated and as we progress through the system, we see pages and pages of text because that was the way that information was presented. But actually, when you see something visually, you're immediately drawn into it. And we talk a lot about knowledge graphs, and a lot of knowledge graph technology isn't actually visualized as a knowledge graph. But here's one example that actually is enabled through the use of knowledge graph technology, and actually can be very, very helpful to people to find what they're looking for, and also to give them certain ideas. So if you, for example, started off your search and you were interested in the MMR vaccine and you'd heard about, some kind of controversies in autism, and you might want to understand more about it, being able to put those terms into a knowledge graph and to visualize the concepts and connections is hugely valuable. And the other thing that's really important is that you see all of these concepts and the connections, and it's just not about knowing that X and Y are connected. It's about understanding why they're connected and getting to the appropriate literature that supports that. And so in a knowledge graph, as we saw earlier through the numbers that are applied to every single concept and connection, everything is explainable. So you can always get to the exact section of the text that is referred to so you can understand exactly why something is appearing. I wanted to talk a little bit about a very, very specific example, to give a concrete example of how AI has been used by a publisher. So one of the things I'm going to talk about is a project that we did with MIT Press. And they were really interested in understanding how AI technology could help them, specifically really looking at their topic hierarchy. So first of all, to give you a little bit of background on the MIT Press taxonomy, which was born in 2017 from the ashes of an outdated non-hierarchical set of subject codes. So first of all, they'd mapped the old codes to the new taxonomy. So the full potential of the taxonomy hadn't been utilized for the backlist, partly to do with the lack of time and human resources to categorize the backlist. And in the new taxonomy, books could be coded as multiple topics to get at the interdisciplinary nature of many of the MIT Press collection of books. And the way in which we use our kind of hierarchy at Yewno is the same way. So one of the things that MIT Press wanted to do was to facilitate a better mapping of titles in their taxonomy to utilize more of the potential in the system. So to fill in the gaps, so to speak. So for all the things in the backlist where they didn't have time or human resources to go back. So if you look at their existing taxonomy, they had a category for genetics and genomics, which is a subtopic of biomedical sciences. The topic didn't exist in their old system, so identifying titles to map to it was impossible. And they only actually had one title identified in that area, and that was manually assigned. But actually at Yewno, we had the title genetics and genomics subtopic as well. And so we were able to identify 21 titles being in that category. So you've gone from 1 to 21, which is a great use of things in the backlist. Another really interesting example was fashion, because the topic did actually exist in the old system, but they hadn't really emphasized fashion as part of the list in the past. So even though the topic was mappable from the old system, the code hadn't been well utilized in the system, but using AI, they identified 11 titles with the fashion subtopic, and they'd only previously identified 2 of those. And the final example is developmental psychology, which is a subtopic in the MIT Press taxonomy, which is the deepest level it goes. And this one had the same mapping issue as genetics, where they had no titles, whereas we were able to identify 24. So, and those 24 titles represented 24% of the, 18% of the entire list. So looking at another example, MIT Press had left room to grow in their taxonomy in certain areas where they felt like they had some books and they were acquiring more books, but didn't yet have enough to include it in the taxonomy. So in these situations, or in cases where a subtopic was just overlooked for whatever reason, using AI can help identify areas in the list that they might want to add. So these are a few examples of topic areas where they had a lot of books, but they weren't covered by the existing taxonomy. So if you take the example of estimation theory, which is a subtopic of mathematics with 131 titles, it wasn't being captured by either their taxonomy or by ZAC or keywords. Another example is activism, which was a subtopic of political science with 83 titles, and workplace culture, which had 68 titles. So for all of these things, they were being overlooked to do with a previous kind of outdated system. And actually there was a lot of value that they could derive from their backlist in each of these specific places. Another example in the MIT Press taxonomy, they have music and sound studies as a subtopic of the arts because it makes sense for their list. Whereas we'd categorized it using our AI, on the other hand, as a separate main topic for music, which had several subtopics of its own. So all of this was granularity that could be super useful to MIT Press and also very interesting for a researcher. So if, for example, somebody in marketing wanted to list all of the music and sound studies books, it would be easy to do in the MIT Press system. But if they wanted to find something, for example, about rap music, that wouldn't be possible. And by the way, if anyone's interested, MIT Press actually has 5 books on rap. And then the final example of a use case in this space is really showing what AI can offer. So the MIT Press categorizes medicine as a subtopic of biomedical sciences, and it has no subtopics of its own. Whereas using AI generated 77 subtopics. So of those 77 subtopics, MIT Press has at least one title in 55 of them, which is really incredibly granular. And it's far beyond what a publisher could feasibly do, using human resources and with a legacy taxonomy. So that's just one example, really, of how AI can help and add a whole new dimension that isn't possible. And then the final example is really focused on backlist and actually driving sales. So we did an experiment with Stanford University Press, and we deliberately selected books that were not going to be influenced by any external factors. And we replaced the BISAC codes, so however many there were, in some cases 1, we replaced them with 3, and then we updated all of the keywords. So the example I'm going to use is a book called Knowledge in the Blood, which was published in 2009. And this is what was said about it in terms of the information available. And then in terms of what happened, this was the code that existed, so education with the subtopic of leadership, and this is what we changed it to. So higher education, teaching methods and materials, and social science, discrimination, and race. And we also found 776 keywords, and typically publishers have anything from 0 to about 12. So this gives, again, that sense of incredible granularity that AI is able to provide using a knowledge graph that wouldn't otherwise be possible. And so really what actually was the outcome of this? So this book had 2,500 lifetime sales. They were selling 25 or 26 a year. And it was increased by a factor of 7, really just in terms of the discoverability. So I'm going to wrap up now and hand back to Clive, but just to sort of summarize, really, AI can do many, many things. And I would say the key things I would think that are enhancements in terms of the publishing sphere are really the ability to dramatically improve semantic metadata, which particularly for older titles might be either non-existent or outdated. Also the opportunity to create much more accurate similarity mappings and to help people find related content. For publishers to be able to build collections, potentially of areas in their portfolio and their backlist in particular that they didn't know they had good coverage of, and also to understand in depth each document and potentially to surface up bits of documents into specific snippets so that people can find what they're looking for without having to read the entire thing. So I'll pause there, and if people do want further information, a couple of contacts, but I'm going to hand back to Clive.
Thank you, Ruth. That was really terrific. It does, again, raise the same issues as before, the fascinating potential of AI. I just see if there's no one's filed any questions. I've got a couple of my own. Obviously, conceptually, it's absolutely amazing, mind-blowing. I'm interested to know, take the MMR knowledge graph, for example. How is that practically created? I mean, how does that come into existence? If you could explain that briefly.
Yeah, absolutely. It's a really great question. And one of the things I'd also like to flag in terms of that question, and I get asked a lot, is about bias. So people always ask me about AI and bias, and does AI create bias? And one of the reasons I use the MMR example is because absolutely AI could be used to create bias if you trained your algorithms to do it that way, but you don't have to. And I think in our perspective, in a knowledge graph, that's absolutely not what we're trying to do. So you can treat information, you can prioritize different things if you wanted to. So you could prioritize either different types of content or different publishers. But if you don't want to do that, the great thing about a knowledge graph is that it will give you all these different perspectives. So it's reading all of the content, it's reading everything that's ever been published on MMR, it's reading everything that's been published on autism. And as you remember from that kind of graph, it also has a concept of controversies in autism. So if you look at that, it's not telling you that, you know, the MMR vaccine does or doesn't cause autism. It's giving you all of the information, and you, the researcher, can then read all of that, and you will make your own decision. So what I really like about the AI is that it can give you that visualization, which can help you understand and help you kind of see what you should be looking into. And then if you do want to read all about those things, you don't then have to wade through, you know,
sure,
and full journal articles. You can go to the exact section of text. And for me, when I look back at being a student and I think about wandering around libraries and bookshelves and, you know, all the amount that you had to wade through sort of pre-mass digitization of content, then, you know, it's just a different world in terms of getting to what you're looking for.
Yes. So the AI itself is doing the reading, is actually learning the material, sifting, sorting, categorizing, and creating the graph in that fashion. Is that right? Have I got the concept right?
Yeah, absolutely. And so the key thing about neural networks compared to legacy technology is that the algorithms are reading the full text. And as they're reading the full text, they're identifying meaning in the form of concepts. And they promote those concepts. They get paired with a definition, and that's how you get the accurate disambiguation. And they're doing it real time. So every time an item of content is published, those connections, those concepts can be updated. And that's the key thing, is it's not a static environment that gets updated, you know, weekly, monthly. It'll be updated real time. And the key thing as well now with neural network technology is that it is understanding the context of what it's reading.
Yeah, fascinating. I don't know quite if you can breathe life into this. I think it's fascinating. You've got that MIT Press example where there were no titles identified and 21 titles. I mean, that seems to be a massive gap. Could you just talk to that for a couple of moments?
It's a really interesting thing. So sometimes, you know, a publisher obviously, you know, might think that they're publishing on a certain area. And some people obviously are very, very large companies and have very, very broad portfolios. And some people are maybe narrower and they focus on one of the sciences or something. So everyone will have a view. And if your view is that you've published on social sciences or physics or chemistry, your hierarchy will be largely geared to what you think you publish on. And you'll probably be mostly right. When I say mostly right, I mean 70 or 80% right. Because as somebody is writing a book, which they might think is about physics, and it might be mostly about physics, but categorically there'll be other things. There'll be things that might be a little bit about chemistry, there might be a bit about biomedical science, there might be a little bit about economics. So there'll be those other bits of books. And even in journal articles, which are much shorter, you'll find a similar thing. So what happens when people create something about what they think they've written about is you by definition are missing all the other things because you haven't got a category for it in the kind of hierarchy that you've created.
Fabulous, Ruth. Thank you so much. I mean, it underlines for me this sort of the heart of Contech is about the way technologies are revolutionizing the creation, dissemination, and consumption of content. And in a nutshell, I think we've talked about nothing else in the last 25, 30 minutes. Really fascinating. Thank you so much for participating for a second time. I do want to tell everyone that Ruth will be back speaking in more depth on how AI will help publishers to better curate their collections, maximize resources, and increase sales, critically important, especially at this time, during Contech Week, which is our main flagship event, and that's taking place on the 16th to the 19th of November. 4 half-day, 4-hour sessions. We've now got a complete program that's available at contechlive.com. We'd love you to go and have a look at that. Our focus on the continuing evolution of the content business, the sorts of things that Ruth is talking about. Please do take a look, and we would love to see you participating in what we're very excited about as our main event in just 10 weeks' time, horrifyingly. Before I finally part with you today, I just wanted to say that we've got another session in 2 weeks' time where Sami Benchbrun, the CEO and co-founder of Moressier, and I will be talking about the question, is the traditional academic conference dead? So please do go and sign up for that one, because I think that might be quite fun. It's our first in a series of fireside chats. All that remains is another very, very big thank you to Ruth. Marvelous talk. Any queries and questions on that, do contact us. There will be a video made available to you very soon. That's all from us. Thank you for joining us. Thanks once again, Ruth. And we will see you again in November. Thanks. Bye-bye.
Bye. Thanks, Catherine.
Bye-bye.
Bye-bye.